All right, ladies and gentlemen, we're back. We're talking about notes 1.6, continued. And again, how to use congruent triangles to write proofs. All right, so today we're talking about, it's called the definition of congruent triangles. Two triangles are congruent if and only if their corresponding parts are congruent. So we're going to use, I call it the alphabet soup. So sometimes you may hear me in class refer to it as the alphabet soup reason. And that's CPCTC. And that acronym stands for corresponding parts of congruent triangles are congruent. Again, so the C, first C is corresponding, the P is parts, the second C is congruent, the T is triangles, and the last C is congruent. So again, that's a mouthful. So if you can find another way to remember that, let Mr. Harper know. So here, this is going to be our final statement, which is once you have proven that true triangles are congruent, you can use this fact and mark any additional sides or angles congruent. So that means if we didn't already say that as part of the proof, that the regular proof before we prove congruence, then anything we say after we've proved the congruent by side, 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 or angle, angle, side, or side, angle, side, once we prove it by one of those theorems, anything else in the triangles will be congruent. All right? So let's start off with our first proof. It says, complete each proof. Here we're given that RL is congruent to DC, it's parallel to DC, and LC is parallel to RD. So again, the first thing we want to do is we want to go ahead and draw our triangles. So we're going to draw our first set of triangles here. Okay. And draw another one down here. Okay. Then we're going to draw two on these sides because these two sides are parallel as well. Okay. So you have to forgive my triangles. So again, by no means am I an artist or claim to be an artist. So, all right. So what we're trying to prove is that angle R is congruent to angle C. So let's start with our first reason. Our first reason is what always? Given. All right. So now what we need to do is we need to start marking our angles. All right. Or sides. Now, if you notice, once we said that these are two sets of parallel lines and we have our diagonal or transversal, we can draw our Z's. So our Z tells us it's alternate interior angles. So that means the angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Okay, so that's why I drew the double lines. 1 and 3 are congruent, 2 and 4 are congruent. So let's start off with our first set of congruent angles, which we said was angle 1 is congruent to angle 3. All right. We want to write alternate interior angles. The second set was angle 2 and angle 4. Again, alternate interior angles. All right. So you could have did this in any order. You could have did 2 and 4 first, and then 1 and 3. It did not matter. But I just chose to go with that as my first one. So again, you could have did it any way you wanted to, but you must say for your statements, angle 1 and angle 3 are congruent, and angle 2 and angle 4 are congruent. All right. So these are so again. Now we need to talk about. You notice the LD is a side they share in common. So therefore, that means LD or DL is congruent to the other DL, and this is by the reflexive property. Because anytime they share a side, that's going to be reflexive. So now that's congruent. So now let's mark our angles and sides. Let's start with the top triangle. So we got an angle, a side, and an angle. So we know it's going to be ASA. So now let's label our triangles. So we have first triangle is triangle RLD is congruent to triangle, remember we got to go in the same order. So since we started with R in the top right-hand corner, the top left-hand corner, we got to go to C in the bottom right-hand corner. So it's going to be C, D, L. So we got to follow the same order. And we're going to say ASA is our reason for that one. Let me draw my ASA a little better. So ASA. All right. So then our last statement is our proof statement, which in this case is angle R is congruent to angle C. Now, since we've proven that the triangles are congruent by ASA, any statements we talk about, any other angles that we didn't already talk about, or any sides we didn't already talk about, are congruent. So here, angle R is congruent to angle C, and this is again our alphabet soup CPCTC. All right. So that's our first proof using the CPCTC theorem. So again, we'll do another one in the next video where we use the same method to prove that a set of sides or another set of angles are congruent. So see you in the next one. Bye.